Dear students, as we have discussed in the previous classes, the descriptive measures of population are known as parameters. Descriptive measures of population are known as parameters. Statistical inference procedures based on parameters are known as parametric procedures. Parametric procedures. Inference procedures based on population parameters are known as parametric procedures. And inference procedures not based on parameters are known as nonparametric. So, statistical inferential procedures are divided into parametric procedures and non-parametric procedures. Inferential procedures based on parameters are parametric. Inferential procedures not based on parameters are non-parametric. But the common statistical practice is to state that most methods that can be applied on the assumption of normality as parametric. So, parametric procedures are based on normal distribution and distributions based on normal distribution. So, if x is normal, z is standard normal, t is studentized version of x, then we will see later f, chi-square, etc. These are all derived from the normal distribution, standard normal, t, f, chi-square. So, inferential procedures based on x is z, t, f, chi-square, etc. are parametric procedures. Chi-square itself consists of parametric and non-parametric, which we will see later. So, inferential procedures not based on the assumption of normality is non-parametric. So, the term parametric is a misnomer. Parametric is a misnomer in the sense that the terminology is not apt to distinguish between parametric and non-parametric. Now, remember this, non-parametric procedures are easy to compute, easy to apply, and non-parametric procedures are also resistant to outliers, whereas they are less powerful compared to parametric procedures like z, t. So, the power of non-parametric procedures are less, even though they are resistant to outliers, and also they are easy to calculate. So, non-parametric procedures require less restrictive assumptions. Non-parametric procedures require less restrictive assumptions about the level of data measurement and also fewer assumptions about probability distributions generating data. So, the assumptions required for non-parametric procedures are less restrictive with respect to level of data measurement, and also the probability distribution from which data has been generated. Remember this, parametric procedures, as the name implies, is based on parameters. Actually, parametric procedures have two interpretations. One, it is based on population parameters, like testing the significance of a mean when population standard deviation is known, is a test. T, when it is unknown, that we have studied. But the usual distinction is parametric procedures are based on normal distribution. Non-parametric procedures are not. So, non-parametric procedures require less restrictive assumptions about the level of data and also the probability distribution from which data has been generated. One consideration determining whether a parametric procedure or a non-parametric procedure is appropriate. A parametric procedure or a non-parametric procedure is appropriate is the scale of measurement. Scale of measurement used for generating data. The scale of measurement used for generating data. As we have studied earlier, there are four scales: nominal scale data, the second is ordinal scale, third is interval scale, the fourth is ratio scale. Nominal scale, ordinal scale, interval scale, and ratio scale. As far as nominal scale data is concerned, measurement is nominal if the data are labels or categories. Labels or categories used to define an attribute or an element. For example, nominal scale variables are numeric or non-numeric. Numeric, for example, social security number. Social security number, numeric nominal scale variable, and non-numeric, color of skin like white, black, etc. Ordinal scale, scale of measurement is ordinal if the data can be used to rank or order observations. Rank or order observations. Ordinal scale is numeric if the ranks are given as 1, 2, 3, etc. Non-numeric if first, second, third, etc. Ordinal scale. Then we have the interval scale. The scale of measurement is interval if the data have properties of ordinal data and interval between observations is expressed in terms of fixed units of measure. And interval data is numeric, always. Interval data is numeric. For example, measurement of temperature. Remember, and the last one is ratio scale. That is, scale of measurement is ratio if it has the property of interval data, property of both the interval data and also that of the ratio of measurement is meaningful, like distance, height, weight, etc. Now, this temperature is an example of interval data, but it is not a ratio scale variable because ratio between two values is not meaningful. we cannot say that 50 degrees Celsius is twice as, 100 degrees Celsius is twice as 50 degrees Celsius. Or another definition is zero temperature does not mean no temperature. Zero is not absolute zero. In the case of ratio scale, zero is absolute zero. Ratio between numbers is meaningful. Now, given this, we can say most of the statistical methods described as parametric require the use of interval scale and ratio scale data. Interval scale and ratio scale data. For such variables, operations like calculation of mean, median, mode, that is descriptive measures, are meaningful. Mean, median, mode, standard deviation, variance, etc. are meaningful. Now, in the case of nominal scale and ordinal scale variables, calculation of descriptive measures is not meaningful. As such, we cannot compute mean, median, mode, etc. for nominal scale and ordinal scale variables. The use of parametric methods is not suitable for nominal scale variables and ordinal scale variables. So, the only way to analyze such data is non-parametric methods. So, remember this, for parametric methods data will be interval scale and ratio scale. For nominal scale and ordinal scale, we cannot compute descriptive measures as estimates of the parameters. So, we cannot use parametric methods. So, in general, non-parametric methods are used in the context of 1. Nominal data, 2. Ordinal data, non-parametric methods, nominal data, ordinal data, and also interval or ratio scale variables, where we cannot assume anything about the probability distribution of variables, that is normality. Normality cannot be assumed. So remember this, non-parametric methods are used with the nominal data, ordinal data, also interval and ratio scale data, provided that we cannot make assumptions about the probability distribution. But parametric methods are more powerful than non-parametric, and parametric methods are based on parameters and also normality. Remember these 2 points. Non-parametric, not based on parameters, not based on any assumptions about the probability distribution. And keep these points in mind. In the next class, we will consider a non-parametric procedure for one population, namely the Wilcoxon signed rank test.